Hey guys, welcome to brainAttic. Today we have another set of problems with us. Such problems are very common in competitive exams like JEE Mains or International Mathematical Olympiads. So if you do want to give it a try, you can pause the video. Otherwise, we can proceed solving the problem. Okay, so the first problem given to us is suppose A and B are two 3 cross 3 invertible matrices such that AB product whole to the power k is equal to a to the power k into b to the power k for k is equal to 2008, 2009 and 2010. Then we have a few options. Option A, A inverse is equal to B inverse. Option B, A inverse B to the power minus 2 into A is equal to B square. C, AB is equal to BA. D, A to the power minus 2 B A square is equal to A to the power minus 1 BA. In the second question we have, let f be a function from R to R, g be a function from R to R and h be a function from R to R, be differentiable functions such that fx is equal to x squared plus 3x plus 2, fx is equal to x and h of g of gx is equal to x for all x belongs to R. Then g dash 2 is equal to 1 by 15, option A. Option B, h dash 1 is equal to 666. Option C, h0 is equal to 16 and option D, h of g of 3 is equal to 36. In the third question we have the number of possible values of n such that n factorial has exactly 20 zeros at the end. So let's begin solving the problem. For the first question, since A and B are invertible matrices, A and B are invertible matrices, then A inverse and B inverse both exist. Also, for every positive integer an and bn are invertible. Now a b to the power k is equal to a power k b power k holds for k equal to 2008, 2009, 2010. Now a b to the power 2008 is equal to a 2008 b 2008. Let this be equation 1. Again a b to the power 2009 is equal to a 2009 b 2009 and let this be equation 2. Finally we have a b 2010 which is equal to a 2010 b 2010, this be equal to equation 3. This is 2010. From equation 2 we get a 2009 b 2009 is equal to ab 2009 which is equal to ab 2008 into ab. Correct? This implies a 2008 into a b 2008 into b, this dot should not be there, is equal to a 2008 b 2008 ab. Let this be equation. So this is using equation 1 only. Now A 2008 and B are invertible. Then we have AB 2008 is equal to B 2008 and A. Similarly, so we name this equation 4. Similarly, using 2 and 3, we get AB 2009 is equal to B 2009 A. Now let this be equation 5. Now using 5, AB B 2009 B 2008 is equal to AB 2009 is equal to B 2009 A. Which is equal to B into B 2008 A, which is B into AB 2008, which is finally BA into B 2008. Thus, AB into B 2008 is equal to BA into B 2008. Now, since B 2008 is invertible, then AB is equal to BA. Now, AB is equal to BA. AB inverse is equal to BA inverse, which is B inverse A inverse is equal to A inverse B inverse. This implies AB inverse A inverse is equal to A inverse into B inverse. This implies A B inverse A inverse is equal to identity B inverse. So this implies AB inverse A inverse is equal to B inverse. And finally we have A power minus 2 B A square is equal to A minus 2 B A into A, which is equal to A minus 2 A B A, which is equal to A minus 1 A power minus 1 A B A, which is equal to A inverse B A. So we look back at our options and we find that option A, option C and option D are correct. Now let's go solve the next problem. So in the second problem we are given that f of x is equal to x cube plus 3x plus 2, function of g of f of x is equal to x, and h of g of x is also equal to x. Since all are differentiable, then f dash x is equal to 3x square plus 3. Again, differentiating g of fx with respect to x. So we will have g dash of fx is equal to 1 by f dash of x. Therefore, g dash of 2 is equal to 1 by f dash of 0, which is equal to 1 by 3, since f dash of 0 is equal to 2. Now we have h of g of x is equal to x. So again, differentiating with respect to x, we will have h dash g of x is equal to 1 by g dash x into g dash g of x. Now from the option we need to solve, from the options, right, we need to solve for h dash of 1, which means g of x equal to 1. We have to solve for g of x equal to 1. So g of x is equal to g inverse 1, which is nothing but f1, which is equal to 6. Again, since we just showed g of x is equal to 6, x is equal to g inverse 6, which is equal to f of 6, which is equal to 236. Now plug in these values for h dash of 1, which is equal to g dash of 6 into g dash of 236, which is equal to f dash of 1 into f dash of 6, which is equal to 6 into 111. Our final answer is 666. Again, for option C, we need to see h of 0. So we will solve for h of 0 now. For h of 0, g of x is equal to 0, which means that g of x is equal to g inverse 0, which is f of 0, which is equal to 2. And since we just showed g of x is equal to 2, x is equal to g inverse of 2, which is equal to f of 2, which is equal to 16. Therefore, h of 0 is equal to 16. Now, putting x to f of x, like, okay, I'll rewrite this. Putting x to f of x, then function h of g of x is equal to f of x from the question itself. Now we know that this g of x is equal to f of is equal to x. So h of g of x is equal to f of x, and h of g of 3 is equal to f of 3, which is equal to 38. 38. Now solving problem number 3. Okay, before that we'll just check our options which is there. So option number B and C are correct. Option A and D do not match. Now solving for problem number 3. We need to find the number of zeros in factorial. So in any number, number of zeros is equal to exponent of 5. This is a thumb rule, you can say, exponent of 5. So if we want 20 zeros, then this must be equal to summation I is equal to 1 to n. This is floor function, inside which we have n divided by 5i. Now, since the floor function is always equal to, is always less than equal to the value, since, therefore we can easily write that 20 is less than equal to summation I is equal to 1 to n, floor function n divided by 5 power I. So this we can again write it as n into 1 by 5 plus 1 by 5 square plus dot dot dot. So since this is an infinite geometric progression, we can give this as n into 1 by 5 divided by 1 minus 1 by 5 whole into bracket. This is nothing but n less than equal to n by 4, which implies that n is greater than equal to 80. Now if n is equal to 80, so we have rounded off our value of n. So if n is equal to 80, exponent of 5 is 80 floor function, 80 divided by 5 in floor function plus 80 by 25, and this is equal to 19. Now if n is equal to 85, exponent of 5 is 85 divided by 5 plus 85 divided by 25, and this is equal to 20. And if n is equal to 90, exponent of 5 is 90 divided by 5 plus 90 divided by 25, which is equal to 21. Therefore, we now know that n belongs to 85, 86, 87, 88 and 89. If you do like this video, hit the like button, subscribe to our channel. Thank you for watching this video. Until again, thank you so much.